Hi friends, in this video we're going to talk about OAuth 2.0 authorization code flow for securing server-side web applications. So if you don't know what OAuth 2.0 specification is, I've already made a video on how OAuth 2.0 is used for centralized authentication and authorization of users and applications. So it's generally common to have multiple applications in a system, and centralizing authentication and authorization helps in seamless login and logout and reduces the duplication of maintaining the users in applications. So OAuth 2.0 aims to solve the problem. So OAuth 2.0 is actually specification. I've already made a video on OAuth 2.0. You can check it out if you don't know what OAuth 2.0 is. I will leave the link of that video in the description. So just to refresh the terminology, the person who is logging in is called user, and the client is the web application that asks for security tokens from the identity server, and the identity server or the OAuth server is the server which implements the OAuth 2.0 security flows. So there are multiple OAuth 2.0 flows, and today we are going to talk about authorization code flow. So this is one of the most used OAuth 2.0 flow. So simply put, authorization code flow is basically the login with Google button or login with Facebook button you see in multiple web applications. So when you click login with Google or login with your company's account in another web application, you are being logged in by Google or your company, and you're being redirected back to your web application with the authentication information. That means the job of authenticating and authorizing you is being delegated to the OAuth server. And this is how single sign-on is possible. So in this video, we're going to talk about how OAuth 2.0 authorization code flow works with an example demonstrating each workflow step. So before starting with explaining the OAuth 2.0 authorization code flow, let's see an example so that you don't get bored. So currently I have a setup running which is running Keycloak as the OAuth server. So I've set up Keycloak as my authorization server. I'm running my Keycloak at localhost 8080, and if I go to the admin console, and my realm my org created in this Keycloak OAuth server, I've already created a user called test user, which we will use in this demo, and we have set the username password of this user, and we have created a client for an application which is test web app here, and this client is registered in this OAuth server. So we will use this client credentials by third-party application for the user to log in through this OAuth server. So it's like login with Google, but here we are using Keycloak, which is running on my local host computer. So I have a Python Flask server, which is running as the web application or the client application, which will use this Keycloak server to log in the user. So I've already run this server. So my server is running at localhost port 3000, and this Flask application is using the web client information, which is created in this Keycloak. And so if I click the login, I'm being redirected to the Keycloak application for logging in. So it's not my application, you can see it's localhost 8080, and I'll just log in with the test user, and after I sign in, I'll be redirected back to my Flask application. And the best part is I did not maintain a user database in this Flask application. After successfully signing in the Keycloak OAuth server, the user details are provided to this Flask application in the ID token, and the ID token is already parsed as user info here. So the username, the user's readable name, and if I had given that email would have also been come here. So this simple Flask application doesn't need to store the user, and there can be multiple applications using the same Keycloak server or the OAuth server to log in users. So you don't need to register user in each application. You can just manage the users in your Keycloak server or whatever OAuth server in the cloud or on-premise or whatever. It's just like an Active Directory server, but for the web. So you can manage your users, you can manage your client applications, and if the client application is a server-side application, you can use authorization code flow just like we shown here now, where the user will be authenticated by the OAuth server, and the user information will also be given to the web application to log in the user and create a session. So now here my application got to know about the user and created a session, and I'm logged in this site. So what are the benefits? The user's information is centralized, and the login screen, the user account management screen, and the user administration screen, everything is implemented by the Keycloak server or the OAuth server. You don't need to securely create all the pages. They're already implemented in a robust way by the OAuth server. So all the work of creating the pages to manage the users and the user management pages and the user administration pages, all those pages need not be done by you. It's already done by the Keycloak server or the OAuth server. And the next benefit is, since the user's information is centrally stored, multiple web applications can use this OAuth server to log in the users. That means whenever you create a new application, you don't need to register all your Office users in that application. You can just link your application to the OAuth server using Authorization Code Flow, and the users can log in seamlessly with their existing credentials. And the next security benefit is each web application which is registered in the OAuth server can have restricted client scopes. That means you can control what user information will be given to the client application. That means if a web application doesn't require to know the user's date of birth, you can control the scope in the OAuth server. That means some applications can have more data about the users and some applications can have less data about the users. And the next amazing benefit is your client application can call another API on behalf of the user using the access token which is provided after the successful login of the user. In our example, I got something called an access token, and let's try to decode this access token. I'm going to a website called jwt.io where you can actually easily inspect the JWTs. So this was our access token. It's just base 64 encoded, so it's not encrypted, it's just encoded, so it can be easily decoded. So I'm using this tool, and here in the JWT body or the access token payload, so you can see there is an attribute called AZP or authorized party, and the authorized party is this web application called test web app. This token was issued by logging in a user with username test user, and what scope this web application has is OpenID, profile, and email. So using this access token, the client web application or this Flask server can make an internal backend request to another APIs on behalf of the user, and that API can validate the request using this access token and check whether this client application or the Flask application in this case has valid scopes or what user was this access token granted for. So based on this information, it can validate whether to give data or not to the Flask application or the client application, and give data only if the request is valid. So you will get an ID token which contains the user information, but also you'll get an access token using which you can do other backend API calls. So these are the advantages if you integrate OAuth 2.0 authorization code flow in your set of applications. And it makes sense to use authorization code flow if you have multiple applications in an organization, which is very normal. We have seen the OAuth 2.0 authorization code in action, but let's try to see what are the steps involved. The first step is the user clicks the login link. So let's try to do that now. And if I click the login link, I'm redirected to the OAuth server. So what happens is that when I send the login request, the Flask server here is redirecting the request to the OAuth server. And just notice this is the authorization endpoint, but along with the endpoint, a lot of inputs are given in this URL query parameters. Let's try to copy this URL and write it in a notepad. This is the authorization endpoint where the user will get the login screen, and here along with the URL you are passing some parameters as query string parameters. So what are the inputs? You are giving response type as code. So this means that you are expecting an authorization code in return from the server after user login. So this is the client ID which identifies which application has actually redirected the user to this OAuth server, and this is the redirect URI. So redirect URI means after logging in the user, the OAuth server will redirect the user to the same client application. So at what URL should the user be redirected? It is specified by the redirect URI. And then the scope. So the scope is OpenID, profile, and email. So you can see the plus and %3. This is all HTML encoding because you can't have spaces and special characters in URLs. So it's basically HTML encoding. That means %3 means colon and %2 means slash and plus means space. So you're given scope equal to OpenID space profile space email. That means these three scopes are being requested by the client application to the OAuth server after logging in the user. And then there is two parameters called state and nonce. So this is for securing the communication and making sure that there is no eavesdropping or malicious code injection by malicious parties. So I will explain the state and nonce in a minute. So all right, the first step is redirecting the user to the OAuth server. Next, the OAuth server sees if the user is logged in or not. In my case, I was not logged in. So now it's asking me to log in. So let's try to log in now. I've already created a user here in this realm called my.org, and the user is test user. So I'm going to log in with this test user credentials. So I'm going to sign in with this user credentials, and after the successful signing, I have come to my web application. But there was something happening in the backend. What happened was that after I did the login, the OAuth server sent an authorization code to the web application. Remember, there is this thing called redirect URI. So after user logs in successfully, the OAuth server will send the authorization code to this redirection URI. So in our case, in the Flask server, you can see there was a request to this redirection URL slash callback, and a lot of parameters were given. Let's try to copy this now in our notepad. So what happened was, after user logged in successfully, the OAuth server sent a request to our Flask server's redirection URI, which was slash callback, and it has also appended a lot of inputs. So one input is state. So remember, we have sent the state in our request for authorization code. The OAuth server has to send the same state to identify which request this response was intended for, because this state binds this request with this response. So when I get the callback in the Flask server, I can now identify which request this response was intended for. And the session state is basically created by the OAuth server. So it's basically the session identifier for the user login, because the user was successfully logged in, a session was created, and this session state identifies the session with this client application. So you don't need to do anything, you just have to pass the session state and keep it with you. And the next important thing is the code. So code is the authorization code which is sent to the client application after the successful user login at the OAuth server. So now our client application has got the authorization code, but still you did not get the user details, because you had to send the authorization code along with client ID and client secret to the OAuth server's token endpoint, and then the OAuth server will validate your authorization code, client ID and client secret, and sees whether you are eligible to get the token or not, and then you will get the ID token and the access token in the result. So all that we could not see here because the whole thing was done by the Flask server. I can just show you the code here. When the request reached the callback endpoint, we have created an authorized token request here, and then after you got the token successfully, we have redirected to the home page, and that's why you are in the home page after successfully logging in. So after you got the authorization code, you're sending the request for the token, right? The request can be something like this. You will create a post request to the token endpoint of the OAuth server, and you will provide the client credentials, which is a client ID and the client secret, in the authorization header as a basic authentication format. So basically you will write basic space base64 encoding of your client ID colon client secret. We can just see what's there here. Let's copy this, paste it in a base64 decoder, and let's try to decode this. And here you can see test web app, which is a client ID colon the client secret. So what we did was, we have just written basics space client ID colon the client secret and converted it into a base64 string and appended here. So you're sending the client ID and client secret in the authorization header, and in the post request body you're telling brand type is authorization code, because we are doing the authorization code flow, and then the redirect URI, and then I'm supplying the code, which is the authorization code. So this way I'm sending my authorization code, client ID and client secret to the token endpoint of the OAuth server, and then if the OAuth server validation passes, I will get the ID token and access token in return, which we are displaying it in our web application. This was the token which was returned by the OAuth server after sending the authorization code, client ID and client secret. And here you can see we have an access token, and you can use this token to make calls on behalf of the user to other APIs, and we have the ID token. Let's try to decode this ID token. Actually, I'm going to copy this ID token and paste it in a jwt.io, and I can see the ID token body here. I've got the information about the user here. I've got the name of the user, which is the display name, and the username, which is test user, the preferred username. And I also got information at what time the authorization occurred, and what is the expiry of this identity token, and to whom this token was issued, which is important, which is the web application test web app, and the type of the token is ID token. So you can do all of these verification checks. You can check the integrity of this JWT using the public key of the OAuth server, and once you're sure, you can authenticate user in your web application and create a session in your application for that user, because you got the user details, and then you can log in the user session in the browser. So that's it. These are the steps. First, the user goes to the login link, and the web application will redirect to the OAuth server's login page, and then after user login successfully, the authorization code will be sent to the redirection URL of web application, and then web application will add client ID and client secret to the authorization code and request for the ID token and access token from the OAuth server, and gets these in return if everything is good. So this is how a user can be logged in using OAuth 2.0 authorization code flow. In this example, we have used Keycloak as an OAuth server, right? Let's try to see what are the settings I have did here. So in Keycloak, I have created a realm for myself called my org, because it's a good practice not to do stuff in master realm. So create a new realm. In my case, I've created a new realm called my org, and I've created a test user for this purpose. So I went to the user section and I've created a user. Here is my user, test user. And then in the credential section, I've created a password for the user. Now let's try to create a client ID, client secret for the web application which we are using. So I've created a web application client here. So just create client, and I've created a client called test web application. So these are the important settings. First, you need to write the client ID correctly, and then you need to give some important URLs here. First thing is the home URL, which is the default URL for the OAuth server to redirect if it doesn't know where to redirect. So this is the home URL or the default URL of the client application. So this can be used by the OAuth server in places like you're logged out, let's go back to the application, and the link should be this one. So it's something like that. The home URL is the default URL of the client application. And the next thing is the valid redirect URLs. So redirect URL is basically the URL where the user will be redirected to after successfully logging in the OAuth server. So in our example, after we logged in, we were redirected to the /callback. So that was actually registered here. If you don't register the valid redirect URL in the OAuth server will not accept the request. And the next thing is the valid post logout redirect URLs. We did not demonstrate this now, but we will demonstrate it in a second. So you have to also register a valid logout redirect URL if you want to. So this URL is basically after you log out of the OAuth server from the application, you will be redirected automatically to this URL. And the main thing is the capability config, where you have to say client authentication. That means you are giving client ID, client secret to the OAuth server. And the authentication flow is standard flow, which is here the authorization code flow. And you can choose if the user has to give consent or not for the scopes which the web application is demanding. In our example, we did not see the consent screen because I've already created the user and gave consent before. So it has remembered the consent given by me previously. But if it's a brand new user and the consent was not given, the first time you log in to the application, you will be shown a screen where you have to provide the consent to share the user information. And these are the standard logout settings. So this way we have registered the client application and the user in the OAuth server. So in authorization code flow, you don't need to write any code for the things to be done by the OAuth server because it comes out of the box. But for the web application, to fetch the authorization code and send the authorization code for the ID token and access token and do all security checks, you need to code yourself in your web application. So this part of the workflow where you ask for the ID token and access token and where you validate the authorization code, all this has to be programmed by you. But fortunately, there are libraries for almost all frameworks being used. For example, for Flask, there is this amazing library called authlib. They give an integration for integrating OAuth 2.0 flow in your Flask application. It's really simple. You just create a OAuth application here and then register your application with all the client ID, client secret, and what is the scope which we need to ask from the server, and what is the server's well-known endpoint. So if you don't know what well-known configuration is, it's basically a page being implemented by the OAuth server where you can see all the endpoints information. So in our example, this is our well-known endpoint configuration. So here you can see a lot of endpoints or the URLs where you can get the data from the OAuth server is being mentioned. You can get the token from this token endpoint, and you can authorize the user from this authorization endpoint. All this information is present in this well-known configuration page. So you have to give the server metadata URL or the well-known configuration page URL. And here I'm implementing the callback URL or the redirect URI. And this takes care of all the round trip which we have mentioned after getting the authorization code. So this passes the authorization code from the server, attaches the client ID and client secret to the server request, and gets the access token for you. So all of this is done by this single function call. And once you get the access token, you can log in the user. So we have used Flask sessions, which is really easy and simple. So just create an attribute called user in the session object and give the token to this key called user. And after logging in, I have redirected to the home page, which is normal home.html. And when the user clicks the login button, we have actually redirected to the OAuth server, right? So that's being done here by using the authorize redirect function, and you just give the redirection URI, that's all. So the URL will be generated by the authlib library. You just give the redirection URI. And now let's talk about the logout. So when I click the logout button, you will hit this function. And when we hit logout, we will log out the user by clearing the session in this application. But that is not sufficient because the user is already logged in the OAuth server. So if you just clear the session and when the user clicks the login again, he'll be seamlessly logged in without asking the credentials because he's already logged in the OAuth server. So you have to log out user from the OAuth server also, and that's where the logout endpoint comes. So you clear the user session from this application and redirect the user to logout in the OAuth server also. So this is the logout endpoint. You also give parameters, which is the post logout redirect URI. Do you notice that if I click logout, I'm redirected seamlessly to this web application. I'm not seeing even the logout screen because when the user gets redirected to the logout endpoint and the user gets logged out from the OAuth server, the user should be redirected to this logged out page. And if I go to the logged out page endpoint, if the user is legitimately not present in the session, just redirected to the home page. And that's why I'm seeing the home page after logging out the user. So that's how you log out the user from your application and also from the OAuth server. Just for fun, let's try to remove this post redirect logout URI. So I'm going to remove this. Let's try to cut this and save our client. And let's try to log in and see, and let's try to log out. When you log out, it will say invalid redirect URI because I did not mention the post logout redirect URI and you are telling to log out to this URI which is not acceptable. So that's why it's telling invalid redirect URI. And you can see here back to application. It's linking to localhost 3000 because I have given the home URL as localhost 3000. So whenever the OAuth server doesn't know where to redirect you, it will show this home link or the back to application link. So that's why you should also give the home URL to the OAuth server. Let's try to ignore this for a second and let's try to not give the URL parameters for post logout redirect. Let's try to remove this and let's try to run our application again and let's try to visit our application and let's try to log in again. So let's try to log out. And it's asking you whether to log out or not because you are not given a redirection URL. So if I log out from here, you will be just in this Keycloak application. So the user has to manually go here and write localhost 3000 or the client application URL. That is why this post logout redirect URI can give a seamless logout experience where the user will click logout for a single time and he will be logged out from the client application and the OAuth server and then be redirected to the client application. So that's why you can use the post logout redirect URI to seamlessly log out the user from the client application and the OAuth server one after the other. So this is how we have implemented such a complicated OAuth 2.0 authorization code flow in a Flask application by using an amazing library called authlib. And you don't need to write much of the code, it's already implemented in the framework. So you just have to give the configuration and then call the functions which are required for the authorization code flow. And the home page which we have implemented here is the home.html template, and here we are seeing if there is a session, that means the user is logged in, show the user's ID and access token. If not, just say welcome guest. And in fact, we are even using the user's username in our template because we have the user info in the session. So the user information is passed into the template as variable. So here the session is basically the user's JSON and the pretty is basically the ID and access token prettified to display in JSON like this. So that's it, guys. This is how you can use OAuth 2.0 authorization code flow to delegate authorization and authentication to a central OAuth server. And this is really beneficial if you have multiple applications running in your organization and you want a single sign-on. And the added benefit is you will have a robust implementation of user storage, user login, and you will also get additional benefit of getting access tokens where you can call APIs on user behalf in the client application. So I hope this explanation makes sense. I've also created a blog post on explaining the OAuth 2.0 authorization code flow. I've given the notes, I've also given the diagrams and the source code and the settings of Keycloak so that you can practice it in your own computer and create your own applications that follow OAuth 2.0 authorization code flow. I have given the source code of the Flask server which acts as a OAuth 2.0 client application. You can copy this code and implement OAuth 2.0 authorization code flow in your Flask applications. There is an excellent article on authorization code flow by Auth0, which also does a great job of explaining the authorization code flow. Please ask questions or post your valuable feedback in the comment section. Hope you like this video, guys. Thank you for watching. Peace.